Hi, my name is Josh Garrick, and today I'll be talking about the basics of chemical equations, different kinds that you might encounter in chemistry class, and just the introductory material that'll help you get started with chemical equations. So first off, we'll start off with the molecular equation. In an aqueous chemical reactions can be written as molecular equations. The complete formula for each compound is shown. So here you can see as an example, we have the reaction of nitric acid plus ammonia to get ammonium nitrate. And you can see from the equation how you're going to set that up based on the actual complete formula for each compound. You're going to give the chemical state, and for all these it's aqueous, but you'll encounter different kinds, and I'll have examples of those as we go on. Coming from the molecular equation, we also have the total ionic equation. Dissociation of reactants and products is emphasized by writing a total ionic equation, and as you can see with the previous equation given, the nitric acid and ammonia, you can see that nitric acid is dissociated because it is a strong acid. It completely dissociates in water, while ammonia does not because of its gaseous form. And moving lower, you can see we also have the net ionic equation. As you can see, spectator ions are ions uninvolved in the chemical reaction. When spectator ions are removed from the total ionic equation, we're given the net ionic equation. As you can see again, we just cancel out the spectator ion, which was the nitrate ion, and we're left with hydrogen plus ammonia equals ammonium nitrate. Moving on to another type of reaction that you'll commonly encounter in chemistry 1310, we have acid-base reactions. Acids are substances that dissolve in water to produce hydrogen or H3O plus ions. Examples, we have HCl, HNO3, H3PO4, and HCN. Bases are substances that dissolve in water to produce the OH ions. Examples of those we have NaOH, CaOH2, and NH3. Strong acids and bases completely dissociate in water. We have two acid-base equations down here as well. First one, hydrochloric acid and water as reactants, and we have our base down here, NaOH. And moving on from that, precipitation reactions are really what just bring everything together. Here, as you can see, a precipitation reaction is an aqueous reaction that produces a solid called a precipitate. So you can see we have our aqueous reactants, BaCl2 and K2SO4, while the products are BaSO4 and 2KCl. BaSO4 is a solid, as you can tell if you look at the solubility table. This sulfate is going to be a solid that is produced in the chemical reaction. So going on to look at the ionic equation below, we have Ba2 plus 2Cl minus plus 2K plus SO4 2 minus. And again, we're going to get BaSO4, which is going to be solid, and 2K plus and 2Cl minus. So that's all of your aqueous solutions are dissociated and split up while your solids stay intact. And in the net ionic equation, you're canceling out everything that shows up on both sides of the equation so that you're left without any spectator ions. So again, we have Ba2 plus aqueous, SO4 2 minus aqueous, and our solid barium sulfate, BaSO4. And that's really the basics of chemical equations that you may encounter in Chemistry 1310. Thanks.